This is Dr. Padma, Professor, Department of ECE from Gokaraja Rangaraja Engineering College, Hyderabad. Would like to discuss on the basics of a satellite. So coming to the basics of satellite, the satellite is, we all know that it is used for the communication purposes, and these satellites are revolving around the earth. So these satellites, when it is been trying to revolve around the earth, it is used as either a geostationary orbit or a geosynchronous orbit. It is placed at a particular location and it is facing the earth, so that the area of coverage from the satellite is called as a footprint area, and these satellites can able to transmit the signal or receive the signal from the earth station. So that is how the satellite is being located in a particular orbit. So depending upon the application, this satellite is how it is being launched. It is being either present at a circular orbit, or it can be launched in an elliptical orbit. So depends upon its application. So when it is placed at a circular orbit, it rotates in a circular fashion with respect to earth. Or if it is placed in an elliptical orbit, the satellite rotates with respect to earth with an elliptical fashion. Whereas though it is either it is in a circular orbit or in an elliptical orbit, the satellite is being placed at some fixed distance, and this satellite is being placed in its position, or it is also called as its home position. So it never moves from its home position. How? This because of the few forces that are being acting onto the satellite. One is the gravitational force, which is also called as an attractive force from the earth. Because of the gravitational pull from the earth, that is an attractive force, and another one is the repulsive force from the satellite, which is called as a centrifugal force. This makes the satellite to move away from the earth. So these two forces are acting exactly opposite to each other, which is making the satellite to be in its position. Because of these two forces that are being acting onto the satellite simultaneously. Apart from these forces, there are many other external forces which are being also applied onto the satellite, but those forces are because of the moon, because of the other planets that are being present in the atmosphere. So these forces can also be made the satellite again to come back to its home position with the help of the thrusters that are being present in the satellites, which continuously monitors the distance and continuously monitors whether it is present in its home position or not. Again, it's come back to its home position because of the thrusters. So here the centrifugal force by the satellite and the attractive force from the gravity, both are making the satellite to be in its position. So if we take the expression of the gravitational force, which is represented as Fg, that is force due to the gravity, which is equal to m into g into capital R by small r whole square, where small m is the mass of the satellite and g is called as the gravitational force, and capital R is the radius of the earth, and small r represents the distance from the satellite uh, towards the center of the earth. So this is how the attractive force or the force of the gravity is being mathematically represented. Coming to the force due to the satellite, which is also called as the centrifugal force, which is represented as Fc, and that is a centrifugal force with respect to satellite, which is mathematically equivalent to m, that is mass of the satellite. R is the distance from the satellite towards the center of the earth. And omega is the angular velocity with which the satellite is been rotating. So m r into w square, that is the force with respect to the satellite. So this is how the force with respect to the earth and the force with respect to the satellite, these both are equal. So we already know that g is the gravitational force which is equal to 9 point g is the gravity, earth's gravity, which is equal to 9.81 meters per second square. So to keep the satellite in its orbit, either it can be a circular orbit or it can be an elliptical orbit, both the forces should be equal, that is Fg should be equal to Fc. So when these two forces are equal, when we equate from the above expressions for Fg and Fc, we will get that the distance r, which is equal to g into r square divided by 2 pi f whole square cube root. So this is how we will calculate the distance r. So this r is the distance from the satellite towards the center of the earth. For a geostationary satellites, this distance is approximately equal to 36,000 kilometers. So that is how we can able to calculate the distance with this expression. So coming to the important parameters that plays a major role in the satellite communication is the angle of inclination and the angle of elevation. So this angle of inclination, which is represented with delta. Okay, so it is defined as the angle between the equatorial plane and the plane at which the satellite orbit is being present. So the angle across the equatorial plane of the earth and the angle at which this is your equatorial plane and this is your angle of inclination towards your satellite, the distance between these two, that is the angle, is called as an angle of inclination. So if this angle of inclination, if it is equal to 0, then what will happen is the satellite is in its equatorial position. That is there is no angle between the equatorial plane and the satellite orbit. So it is called as an equatorial plane. So if the satellite is in an equatorial position, then there is no two different positions. That is, if the satellite is rotating in an elliptical fashion, there is an every chance that satellite is coming towards the earth or satellite is going away from the earth. These 2 points. Why? Because the satellite is rotating in an elliptical fashion. There are two focal points. So this is one focal point, that is the center of your ellipse, and this another focal point which is the center of your earth. So center of your earth acts like one focal point and another focal point is somewhere here. So when the satellite is trying to rotate, so it comes very much closer towards the earth, which is called as a perigee point. So when the satellite is coming closer to the earth, the distance is, when you measure the distance between the satellite and the earth, that is a minimum distance, which is called as perigee. And if you are continuously measuring the distance, the farthest point from the earth is called as an apogee point. So the distance very much farther from the center of the earth, from the center of the earth towards the satellite, when you are trying to measure the distance is maximum. It is called as an apogee point. So apogee and perigee plays a major role when the satellite is rotating in an elliptical fashion. If the satellite is rotating in a circular fashion, so it maintains the fixed distance. So there is no smallest distance or the farthest distance. So if it is rotating in a circular orbit, the distance remains the same. If it is in an elliptical fashion, there are two different points are being observed from the satellite, that is the perigee point and the apogee point are being observed. So if you look at the figure, so this black plane represent an equatorial plane. So with respect to this equatorial plane, so your satellite is rotating with some angle. So this is the plane of your satellite. So the angle between this satellite plane and the equatorial plane is angle of inclination, which is equal to delta. So if this angle is equal to 0, then what happened? There is no difference, or there is no angle. It is equal to 0 means the satellite angle is also with respect to your equatorial plane. So coming to an angle of elevation. So this angle of elevation is defined as the angle between the center of the satellite beam towards the tangential point of the earth. So if you observe this figure, so this is the earth. So the circular or the curved path is the path of the earth, uh, or how the earth is being present. And if you draw from this earth, if you draw a tangential line with respect to the satellite towards the earth, from the satellite towards the earth, you are taking a how the signal is being applied onto the earth. This is called as a footprint area. This is how the satellite is radiating to this distance is being covered by the satellite, which is called as a footprint area. So if you take the center point and if you draw a straight line from the satellite which is touching onto the ground, and from there if you draw a tangential line, this is your tangential line. So this is your angle is represented by epsilon. This angle is called as an angle of inclination. So I once again repeat, this is your satellite. From the satellite, this is the signal how from the satellite it is being applied onto the earth. So this is the total area of coverage of your satellite, which is called as a footprint area. So when you take a center beam, that is the center line which is passing and it is being applied onto the earth. So with respect to that line, you are drawing a tangential towards the earth. So this is your tangential line touching that point. So this angle is called as an angle of inclination, which is represented by epsilon. These are the few basic points need to be remembered for the satellite. Thank you.